Alright, so now let's do the problem number 5, the last problem in the sequence of problems that I handed out. So this problem, let's read the problem. If the current in the 4 ohm resistor is 1.4 amperes, what is the magnitude of the potential difference VA minus VB? Now let's take a look at this problem. So it asks you to find the potential difference VA minus VB. That's all we need. So I could do this using a similar technique like problem 4. Remember, we just did problem 4, and the way we did was we used some principles from Kirchhoff's loop law, going from point A to point B through this path. How much potential do I gain or lose, and so on. And we were able to do that in problem 4. Now, if I try to do the same thing in this case? Suppose I want to go from suppose I want to find the potential difference VA minus VB. Why don't I just go from point A to B? For example, how about going from A to G to H to B? Well, let's take a look. Now, okay, the problem is, so I go through the 2 ohm resistor, and if I go through the 2 ohm resistor, I lose potential 2 times I1. Oh, but wait a minute, I do not know what the value of I1 is. What do I do? Okay, what if I take another path? How about going from, instead of going through I1, how about going from A to G and then to H and then to, sorry, I did that already. How about going from A to G to C to F to H to B, right? What if I take this loop and use the same principle as in problem 4? Well, wait a minute, I get stuck at the same point, right? Because I do not know the value of my current I1, so without that I will not be able to calculate, for example, how much potential I lose going through the 2 ohm resistor, right? So you can see that the problem goes back and forth. So in order to solve this problem, we need to know the value of I1, the value of I2, and the value of I3, right? Well, I3 you already know, but you still need to know I1 and I2. So doing this problem takes multiple steps, right? So let's do this. Okay, now this is what I do. First I start by labeling each of the junctions. As you can see, I have labeled A, B, C, D, E, F, G, H. Right? So now it doesn't matter what label you give it, but you just have to label the junctions. Right? So now let me do this. Now again, several ways of doing the problem, but let me take one approach and let me explain that. Now this is what I'm going to do. I'm going to go from point C and then back to point C in a loop like this. So I'm going to do C, D, E, F, C, right? And for this path, I'm going to use Kirchhoff's loop law. Let's do that. So what do I have? So going from C, D, E, F, C, I'm going through the 8 ohm resistor, and I know that the current through the 8 ohm resistor is I3 in this case. So I have minus 12 times I3. Well, actually, I combined this. I have an 8 and a 4 together. They make it a 12. So I just considered this as a 12. So minus 12 times I3 minus 16, because so I go through the 8, I go through the 4, and then the next thing I come across is the 16 ohm resistor. 16 ohms is, and the current through the 16 ohm resistor is, so okay, yeah, we need to pay attention here. What is the current through the 16 ohm resistor? Yeah, say that again. Did you say I3? No, it is not I3 because, okay, you got a current of I3 going from F to C, but please remember you also have a current of I2 going from C to F. So you could tell me, hey Dr. Aravind, the current through the 16 ohm resistor is I3 minus I2 going from F to C. Then you would be correct. Or you could tell me that the current through the 16 ohm resistor is I2 minus I3 going from C to F. You would be correct as well. Right? So this is what I did. So I take minus 16 times I3 minus I2. So this is the current in the direction in which we are traversing. So I3 minus I2. So we lose potential. So minus, and then this has got to be equal to 0 because I'm coming back to the same point. So I should neither gain potential nor lose potential. Right? So what do I have? So you can expand this. I have negative 12i3 and then negative 16i3. So that makes it negative 28i3 plus, I have a negative here and a negative here. Negative of a negative is positive. So plus 16 times i2 being equal to 0. Now I know the value of i3 already. The problem tells me that i3 is 1.4 amperes. So if I substitute that, I have minus 28 times 1.4 plus 16 times i2 is equal to 0. So if you do that, you find that the value of your i2 is going to be how much? You can solve this algebraic equation to find out. So that would be 28 times 1.4 divided by 16. So which means that the value of your i2 you will obtain is going to be 2.45 amperes. Right? So that's the value of my current i2. i2 is 2.45 amperes. Very good. How about the value of i1? So now that I know the value of i2, I know how much current goes through the 2 ohm resistor if I know the value of, or I can use that information to solve for the value of i1. So that's what I'll do. So I'm going to go through a complete full loop here, except that in this case, since I'm interested in finding the value of i1, I'll take a different loop this time. So I'm going to consider this loop, GCFHG, 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 complete loop. Right, and we can go through the same procedure. So you see that I'm going through a 2 ohm resistor, and the current through the 2 ohm resistor is i2. So I have minus 2 times i2, and then I have the 16 ohm resistor, and in this direction I'm going from C to F this time. So the current through the 16 ohm resistor from C to F is of course i2 minus i3. So I have minus 16 times i2 minus i3, right? And then I have the 2 ohm resistor, and in the direction of my travel, the current is going to be i2 minus i1. So I have this minus 2 times i2 minus i1, and this value has got to be equal to 0 because I come back to the same point. So I should neither gain potential nor lose potential. So you can use the value of i2 that you already know from here. You can substitute the value of i2 to be 2.45 here. And you know the value of i3 as well. i3 is going to be, so I'm going to take the value of i2 and substitute it here. And then I know the value of i3. i3 is going to be 1.4 amperes. So I'm going to take the value of i3 and substitute it here, and then the only variable you will have in this equation is i1, right? So you can use algebra to figure out the value of i1. If you do that, you will find that the value of your i1 is 13.3 amperes, right? Please do this algebra and verify for yourself. Do not just believe me, right? Make sure that's a good exercise, and it will also give you practice on how to do these types of problems. Okay, are we good so far? So just make sure you're able to do this. So that actually, with that, we are done with most of the work on this problem. So only the last step is remaining. Let me highlight the last step here. Okay, so the last step also involves the use of Kirchhoff's voltage law or the Kirchhoff's loop law. So let me highlight that. So on the last step, this is what I do. I want to find out, this is going to be very similar to what we did in problem 4. I'm going to take some path from A to B, and I'm going to find out how much potential I gain or lose along the way. So I'm going to consider the loop AGHB. Well, this is not a complete loop. This is not a closed loop. So I go from AGHB. So I start at A, end at B. So this is not a complete loop. Right? So if I consider this, I start from VA. So my initial starting point is VA. Starting voltage is VA. Then I go through the 2 ohm resistor. and I'm going in so I lose a potential of 2 times I1, so VA minus 2 times 13.3, because the value of I1 is 13.3, we just figured it out, amperes. So minus 2 times, and then I have another 2 ohm resistor, and the current through the 2 ohm resistor is I1 minus I2 in the direction in which I'm moving, right? So which is minus 2 times 13.3 minus 2.45 amperes, right? So this should be equal to my VB, right? Because I start from A, I go through this, and then I end up at point B. So that should be the potential I should find. So if you do the algebra, you can just rearrange this equation to write down my VA minus VB being equal to 2 times 13.3 volts plus 2 times 13.3 volts minus 2.45 volts, right? Again, I'm suppressing the units just for the sake of clarity. So if you do that, you will find that this is going to be equal to approximately 48 or 48.3 volts, right? So which means that your correct answer choice is D, right? So that solves all the 5 problems that I handed out. Please make sure, so even though please watch the video again and again as many times as you like. Please make sure you achieve a mastery of this subject, right? And so I would suggest, close your work and try doing these problems on your own now, just to make sure you have achieved mastery, right? So with that, I'll stop the video here, and good luck.